Hello everyone, welcome back. We're tackling another FRQ today, and before we get started, just a reminder, due to COVID-19, we got a little modified structure this year. Your exam is only going to be FRQs. Really, it's just going to be two questions. The first one, worth 65%, is going to be based on arrays or ArrayList. They tell us that. Question two, only worth 35%. Also notice these time differences based on methods and control structures. Now, they give you, if you go and find this data online, they'll give you examples from 2019. Questions 1 and 3 from 2019 represent these individual ideas. And so what we're doing is working backwards, taking a look at FRQs based on these concepts. A note, you can use an IDE, but you don't have to. I would. Okay, they tell us that we are going to basically be modifying the normal units, right? Normally CSA is based on these 10 units. We're chopping off these last 3. This is probably more telling than anything else because the one I'm going to show you, it does have an array/array list, but it also makes heavy use of strings. Now, where do strings fit in? Well, they're definitely not 2D array, inheritance, or recursion, so strings must be somewhere in these 7 units. My guess is unit 2 using objects. So what that means is, looking at this, you don't see anything about strings. But looking at this, I interpret this as you still need to know strings. You still need to be prepared to work with strings on an FRQ. So looking at 2016, question number 2. This question involves 2 classes that are used to process log messages. A list of sample log messages is given below. Each of these we see there is something colon something. Something colon something. Log messages have the format of machine ID. So these are machine IDs over here on this left-hand side. Colon description, where machine ID identifies the computer and description describes the event being logged. We can go bigger, right? Exactly 1 colon appears in a log messages. That's important. There are no blanks either immediately before or immediately after the colon. Also super important. Both those would show up as preconditions in our method headers. So here is the following log message class used to represent a log message. We'll be recreating this. This one happens in part A. This is a constructor. I can tell it has the same name as the class. And despite having parentheses and parameters, there's no return type. Down here, this one's going to be done in part B, but we want to know, does it contain a word? And it looks like we're passing in a keyword. We return true if the description in this log message properly contains keywords. So important, we're going to be looking through the description. Then there's just a couple of getters. Why don't we open up IntelliJ and go ahead and plug in this stuff here. So in IntelliJ, I'm going to be making a new project by going to File, New Project. I'm going to use version 11. Doesn't matter, the class is based on version 7. We're going to expand the 2016 folder in my case. And this is problem number 2. So within that, I'm doing problem number 2. Okay, that's just our project folder. So I'm going to expand the project, right click on the SRC. The class that's in question is called log message. Right, that's the one that we're going to start with. This is an object class, right? It's used to create objects. We can tell because there's no static methods. We do have a constructor. I'm just going to grab all of this, copy, and paste it in. Still going to be okay. Right, we got 2 instance variables. Both are strings. They put them on separate lines. We have this constructor that we're going to do in part A. Oh, that's not working like I want. There we go. There's the header. We're going to be doing that one in part A, this one in part B, and then there's just some getters, some accessor methods. And it's mad at me because this needs to be on its own line, representing the end of the class. So we have our class. We got two instance variables. We see a constructor. It's grayed out because we have not used it yet, and that's perfectly fine. This particular method is mad at me because it needs to return a Boolean. Why don't we throw in something just so that it's happy? And then these are just some getters. Okay, so this is the start of our class. Let's scroll down. Part A, write the constructor for log message. It must initialize the private data of the object, the instance variables, so that get machine ID returns the machine ID. Get machine ID, this is the accessor method that they gave us. Right? When it's referring to machine ID, it's talking about this instance variable. It is our job to initialize it in the constructor, which is what we're writing here in part A. And the description is going to be the description. So with our log message, we take in a string, which is the entire message. It's one of these, right? This message is going to have effectively the, what is this, machine ID colon description. And they gave us all this stuff about how there's going to be no blanks on either side. There's going to be a colon. They summarize this with this sweet precondition. It's valid. Cool. So let's write this constructor, right? Again, I'm going to have something coming in, and you know what? I'm going to put an example here of what a valid log message looks like. Example, and let's just plug in one of these. Right, we're going to see valid log messages. Example, machine ID, colon, description. So that's what this is. That's what message is going to be. It's going to be something in this format. So what I want to do is separate this from this and put them in the respective instance variables. Sweet. So help me out in chat. We know there's going to be a colon, and everything before the colon is the machine ID. Everything after the colon is our description. So the most important thing is, where's the colon at? I need to find that. Absolutely. It's in our subset, index of. So I'm going to maybe pull that out, save it into a variable. I'm going to take this entire message and look for the colon. Right? We'll look through message, and we're looking through it using index of. And what we're looking for is a colon. You can put it in double quotes. Index of is overloaded, so we could actually just use single quotes if we wanted to. We're going to get the same result. We're guaranteed to have a colon in there. So I'm going to get some type of non-negative value for I. So now that I know where the colon is at, I'm actually okay to cut substrings. I want to basically take the substring, everything beginning from index 0 up to our colon. Right? The machine ID is going to be a substring of message, starting at the very beginning, which is index 0, up to the colon. Keep in mind, with substring, the indices are inclusive, exclusive. So simply put, I. In this example, I is going to be this index here. We're going to get a substring from index 0 up to I. Inclusive, exclusive. That is my machine ID. Let's cut our description, and simply put, it's a message beginning at this index, but I don't want the colon in my description. I just want this part, right? I is right here. I want to start here and then just go through the rest of the string. So here we're using the overloaded version of substring. I'm going to start at I plus 1 and go through the rest of the string. This FRQ is from 2016, number 2. And that's it. This is it for the constructor. We take in a message that looks like this. We're going to separate the machine ID from the description and save them into the respective instance variables. Let's look at part 2. Part B, I should say. Write the log message method contains word, which returns true if the description in the log message properly contains a given keyword and returns false otherwise. A description properly contains a keyword if all 3 of the following conditions are true. You know they got to throw some quirks in here, otherwise we could just use the contains method. The keyword is a substring of the description. The keyword is either at the beginning of the description or it is immediately preceded by a space. The keyword is either at the beginning of the description or it is immediately preceded by a space. The keyword is either at the end of the description or is immediately followed by a space. The following table shows several examples. Now, things to keep in mind about these examples. They're going to give you examples. They're just that, examples. Sometimes students tend to take examples as law or the only thing that they will possibly test. That is not the case. These are just examples, right? Here, descriptions that properly contain disk. Disk. Error on disk. Here we see disk and there is a space in front of it. Error on disk. We see disk and there's a space in front of it here. We also have disk with a space in front of or behind it there. Error on disk. Here we have disk with a space on either side. Okay, all that kind of makes sense. Descriptions that do not contain disk. Okay, it is case sensitive. Error on disk 3. We find disk. There is a space in front of it. However, it's not isolated, we would say maybe, because there's a 3 after it. This is a little unique. We basically want just the word disk. Error on disk. Here we got disk, right? But there's no space before or after it. And then likewise here we have disk. So you can see that the contains method would trigger for these 3 here. Index of, likewise, would trigger for these 3. But I got to do more than that. Ideas. What if we added a space at the beginning and end of the message and then use contains? Well, what about here? There you go. You're talking about, let's not just look for disk. Let's look for disk with a space, beginning, and we really want, the idea of looking for space, disk, space, we potentially have a problem. For instance, I mean, this doesn't contain disk, space, disk. Sorry, space, disk, space. Neither does this one. You're saying, what if we just took the entire message, added spaces at the beginning and end? That way, when we look for space, disk, space, I like this. Oh, this sounds smart. Let's see what we got. So here is the suggestion. Let's maybe bring in some of our example stuff so we have something to work with. Right? The suggestion in chat is, let's look for disk. Now, the problem with looking for that is, hold on, let me bring in like a positive case. The problem with looking for disk is that it wouldn't find it in our positive case. And what do I mean by look? Well, let's say that we want to look through our description, and we want to know, does our description contains, by the way, not in the subset. So if you're watching this video from outside my class, maybe you're not familiar with that, but contains just returns a true or false. It's a little bit more limited than index of, but it's going to tell us, it's going to look through this string for whatever we put here. And what we want to look for is our keyword. In our example, we would be looking through, right? Look through this for disk. Right? This is effectively what contains does. We're going to look through error on disk, the description for disk. But what I want is an isolated disk. So the idea is, let's put spaces around it, which is really brilliant, except in this case, it should get a positive, but because there's no space at the end, we got a problem. Now, the idea is, what if we take this message, just modify it a little bit. Let's put spaces on either end of that message. That way, when we look for this, right, it's right there. Oh, this sounds pretty good. Now, one of the things you want to be careful about is we don't actually want to modify description. So what we can do is basically make a copy of it. We'll call it des, and it is going to be description. It's going to be space plus description plus a space on the other end. All right, so I'm going to take the description, I'll add spaces to the other ends, because what I'm going to look for is the keyword with spaces also on the other end. Why don't we go ahead and modify our keyword to be spaces on either side of it. And the reason I'm doing this is I don't really want to mess up my keyword. I don't really want to mess up my description. I'm just going to make these temporary variables that help me execute what I'm trying to do without modifying any persistent data. I'm then going to look through des. Keep in mind it's the modified version of description. And what I'm looking for, we want to know, does it contain? And I can actually do this all at the point of return. We'll look through our description to see if it contains our keyword. And I believe it is as easy as that. We'll try it out here in just a moment. Actually, let's go ahead and maybe make our driver and do some testing. I'm going to plug in a main method. We'll create a log message. And I need to pass in something. I'm going to pass in, I would like to test the ones that they have here. Right, so these are descriptions. Really, our machine ID doesn't matter that much at the moment, so I'm just going to grab, why don't we grab this guy right here? Oh, I don't want to launch Blizzard stuff just yet. So we're going to create a log message that is this. And what I want to know is, does that log message contain word disk? Right? Notice what I'm looking for is not space, disk, space here. That gets done inside of this method, contains word. So I'm going to run this guy, and we should get a pretty obvious true. Right? Because I have disk, and it is isolated, if you will. Now, one of the fringe cases is going to be, one of the test cases is going to be, well, what if disk appears at the end? This should be true. So I'm going to run it. And you see we get a true value again. What ends up happening is that this is the message that goes in. Really, this is the description that we end up working with. And you notice there is no spaces on the sides of it. In fact, if I were to take it, if we take our log message and we get the description, you'll notice that it's not modified. It's actually just this section right here, right? Error on disk, right? And notice when I highlight it, there's no spaces at the beginning or end because this contains word is actually not modifying it. Just to make sure our constructor is doing what we want it to, why don't we get the machine ID as well and see that it is isolated. No colons in either. Sweet. I'm pretty happy with those, part A and part B. That's real clever with this space thing. Let's jump down to part C, which is where the ArrayList actually comes in. The system log class represents a list of log message objects and provides a method that removes and returns a list of all log messages, if any, that properly contain a given keyword. The message and the return list appear in the same order in which they originally appeared in the system log. If no message properly contains the keyword, an empty list is returned. The declaration of the system log class is shown below. So we're going to have to end up writing this class. Why don't I copy and paste this bad boy, and maybe we can talk about it in IntelliJ. I'm going to right click on the SRC, make a new Java class. It's called what? System log. And I'll highlight everything, paste my code directly from the FRQ. So hopefully we don't have to finagle too much here. We got a private list. Keep in mind, list is an interface. ArrayList is a list. It's beneath it in the class hierarchy. For all intents and purposes, the only list you know is ArrayList. And they do these with the newer FRQs. I would suspect that the FRQ you get, if it has an ArrayList question, it'll say ArrayList and not list. But these older FRQs, they were still trying to make use of that interface. Ooh, look at that comment. All right. So remove messages is going to take in a keyword. And the idea is it's going to remove them from this bad boy and spit out the ones that got removed. Interesting. Removes from the system log all entries whose descriptions properly contain keyword and returns a list, possibly empty, right, if it doesn't find any that contains the keyword, containing the removed entries. Post condition, entries in the return list properly contain keyword. Okay. We can basically, I think when we flip back to our description, we're going to see, we can assume that the contains keyword or the contains word method that we wrote here in the log message class works as intended. So the returns a list properly contain keyword and are in the order in which they appeared in the system log. What that means is you just go through in a natural beginning to end order, and as you encounter it, you remove it then. The remaining entries in the system log do not properly contain keyword and are in their original order. We're going to remove them from MessageList, and we're not going to change the order of MessageList in the process. And the return list is empty if nothing contains the keyword. So maybe they got some examples. Why don't we take a look? Let's see here. For example, assume that the log is a system log. Okay, this is just a variable that's creating a system log object. It initially has 6 log messages in it, these 6 here. Then we're going to call remove from that object disk. Okay, from the contains word that we just saw, this one has an isolated disk, so it would get removed. This one has an isolated disk, so it would get removed. This one does. This one does not. So it should still stay there. So we should end up removing 1, 2, 3 things. And we see that down here, that 3 things did get removed. Oh, am I wrong on this one? Representing the following log messages, right? This has disk, and this has disk, right? Yeah, these are the 3 that got removed. And notice that this one is still there in the log object. So what we have is our instance variable. We'll have to make our constructor ourselves. Actually, why don't we just do that? I'm going to do public system log. We're going to take in a list. You could type ArrayList here and it'd be perfectly fine. And all we're going to do is end up saving it into the variable. I'm writing this constructor not for the FRQ, but so we can test it. So we'll take our message list and set it equal to list. Right? We have a parameter come in, we just save it in, and that is just for testing purposes. Because I want to be able to then go through it. Right? We have a keyword that we're looking through. We're going to loop through this array list. I'm going to call it array list. I know it says list here. This is an array list because it's the only concrete list that we know. We're going to loop through message list, and with each iteration we're going to ask, does the current log message object, right? Keep in mind this array list, each individual element is a log message. I'll ask, does that log message contain the keyword? We'll use our log message method, contains word. If it does, we remove it. We'll add it to a list that we need to return. So the first thing I actually need to do is create a list. So I'm going to create a log message list. I'm going to call it RTN. I plan on returning it. And it is a new array list of log message. A couple of things I'll touch on, right? Notice this is gray. We don't have to do this. You could just leave that off and you're perfectly fine. What you'll see most frequently on the AP exam is they leave it intact. The other thing is, notice that I'm creating an array list. List is an interface. You can't actually make a list. It's abstract. If I try to make a list, I get a message like this. And if we scroll over it, list is abstract and cannot be instantiated. The only concrete list we know is ArrayList. Now that being said, you don't have to do this on this side, right? You could let those match, and we're going to ultimately achieve the same goal. Ultimately, this needs to return a list. Well, ArrayList is a list. It is beneath it in the class hierarchy. Either of these work. First thing I'm going to do is create this bad boy. It's empty. There's nothing in it. As I find things that match my keyword, as I find log messages whose descriptions contain the keyword, then we're going to remove them and we're going to put them in this list because ultimately I'm going to return it. In fact, we can go ahead and do that and spit it back out so we don't forget that you frequently would lose a point if you fail to return in a method that specifies a return statement. Also notice this isn't mad at me, right? We are returning a list. Even if I said ArrayList, still not mad at me. ArrayList is a list. Okay, so now what I want to do is loop through. I am looping through our message list, the instance variable, right? So I'm going to say for. I'm going to use a for each loop here, and then we're going to see why it's wrong. We'll say for each log message, we'll call it log message, thank you IntelliJ, in message list. I'm looping through the instance variables. The purple coding here is letting me know that that is the instance variable. If the current log message contains word keyword, then it is one that I want to remove. Okay, so I'm going to do that. I'm going to remove it from my message list. So I want to do message list.remove. What do I want to remove? I want to remove the current log message. Okay, now right here, this is already, no, sorry, ignore that. So this removes it from message list. I also want this exact same thing to get added to RTN. We're going to look at a couple of ways that you can, in theory, do that. One is create a variable, right? So, sorry, I don't need to create a variable. I could just take the log message and then add it to RTN. We could say RTN.add the current log message. I'm inside the if statement, so at this point I've already verified this is a log message that I want to get rid of. I'm going to first add it to my RTN. I'm then going to remove it from message list. Now, big brain time, remove, let's see if I can get a signature here in IntelliJ without having to actually do anything. Remove, that one returns the Boolean. I lied. Okay, so if we use a for each loop, this is the route that we're going to have to go, and we're going to try this. Here's our approach. We have an empty array list starting out. We're going to loop through our message list. With each iteration, I'm going to ask, does the current log message contain the keyword that I'm looking for? If so, it's one I want to remove. I will first add it to RTN, which was empty, but it now has messages that have been removed. We then remove it from our message list. That is the instance variable, part of this system log. After I go through the entire message list, we'll return RTN. Let's try this out. In my driver, I'm going to recreate their example. So I've grabbed this guy. I'm in the driver. Let's create a log message. Hover over that, import that guy. What do they call it? They called it the log. Nope, sorry. That's a system log. We'll come back to that. This is just a list. That's a new array list of log message. Nope, just strings. What is this taking in? Log messages, right? Okay. We'll get there, I promise. I want to do list.add, and we'll get the first one in here. Oh, that formatting's rough. Let me see if I can clean it up here in a notepad easier. All right, there's my 6 messages. So what I'm going to do is create just one at a time log messages consisting of these things. So I'll take my list. We're going to add, keep in mind this list consists of log messages, a new log message passing in my first one. And I'm going to do this for all of them. We're going to create a new log message consisting of the next guy. List.add a new log message. Bit more work than yesterday's, but I at least have some concrete examples to really test this, and that, gosh, that helps so much. Okay, ooh, too fast. So I'm just creating a list of log messages so that we can come in here and create our system log object called the log, and it is a new system log made from this list of log messages. I probably am going to want some type of toString so I can see what this thing looks like after everything is said and done. Why don't we alt insert a toString and then modify it heavily. I would really kind of like each one to, we can take our log message. I'm in log message creating a toString because what I'm going to want is that after we print off a log message, I want to create a new line. That way we get something a little bit cleaner. Maybe we get rid of some of this other garbage because what I would really want is it to just come out looking just like this. Okay, so what that means is it's really just the original message, a machine ID along with a description. And then I'm going to plug in a new line here so that our final printout looks very clean. And our system log, let's just print off the message list. Okay, sweet. Okay, I'm going to start, let's print off our log. So let's see what it looks like. This is testing my toString more than anything else and making sure that all these things are going in there. So when I run this bad boy, sweet brackets. Close enough. So we have our description, or sorry, our machine IDs, descriptions for each of them, and there's the 6 that are there. And what I wanted to do is test next the remove method. We want to take our system log and we want to remove messages, and based on the keyword disk. So that should get rid of everything where disk is isolated, which is this message here, this message here, and this message here. Let's try that. And this is going to give us a problem, not related to my toString, but we get concurrent modification exception. Now this occurs when you're using a for each loop and you're trying to remove messages. Here I'm using a for each loop and I'm removing as I'm iterating through it. You can't do that. The logistics behind this are kind of outside the scope of this class. I like to think about it as when the loop first starts executing, it figures out what the size is, and if that changes midway through, you got a problem. So you can't remove. So what this means is the only way to really solve this one is using a for loop. So I'm going to do that. In IntelliJ, our short key is for I. We'll start I at index 0. I am looping through MessageList. Okay? Now, what's going to be the problem with using a for loop and looping through MessageList? All I'm doing is looping. I'm starting at the very beginning and I'm going to the very end. What could possibly go wrong? Help me out, chat. Clean up my toString here so that we don't have this nonsense. Let's just loop through for each log message in MessageList. We'll just add it to RTN. And after the loop is over, we spit it back out. That's going to clean up that toString. The problem with using a for loop, not particularly the problem for us is we plan on removing things. Why is that a problem? Well, when you use a for loop going through, let's see. If the current element contains the word that I'm looking for. So if MessageList.getI, right? MessageList is a list or array list of log messages. MessageList.getI is a log message. I want to know, does that log message contain the keyword? If it does, I have found a log message I want to remove. Okay, that's easy. We add it to RTN. MessageList.getI gets added to RTN. We're then going to remove it. So we're going to take MessageList and we're going to remove MessageList.getI. Now, one thing I would consider is notice that here I got MessageList.getI, and here I got MessageList.getI, and here I have MessageList.getI. Save that into a variable. That's one thing I would consider. Okay, so this makes sense, right? We loop through MessageList. If the current element contains the keyword that I'm looking for, we add it to RTN, and then we remove it. Okay, that should work. This should be hunky-dory. Yet when I remove looking for disk, here it is in its original contents. I want to get rid of anything that contains the keyword disk, which is that guy, and that guy. And you see, I missed one. Why? Well, whenever we're looping through, right, I is here on this very first log message. We'll ask, does that one contain disk? No. I is here. On this one, we would ask, does this one contain disk? Yes, we remove it. Sweet. Because this array list size is dynamic, these things are going to shift to cover up that gap, right? I then increments, and I is actually on this one at that point. We would ask, does it contain disk? Yes. So we get rid of it, right? These things are going to shift and fill up that gap. And then I increments. And what's going to end up happening is that I is now on this log message, meaning I end up skipping this one. There's ways to handle this. One is, anytime we do this, we can do an I minus minus. And that will kind of counteract the I plus plus that happens here, right? Anytime this happens, I'm going to end up removing a thing. I would then subtract I to counteract the I plus plus that is happening here. That's kind of, I don't like the way this looks. What I tend to recommend, if you are looking to remove things using a for loop in an array list, is go in reverse. So when these things shift, you don't have that problem. So let's rewrite this loop going in reverse. I'm going to start at the very end of my message list. The last element is MessageList.size minus 1, right? Size would be out of bounds. Because we're going from end to beginning, I'll keep going as long as I is greater than or equal to 0. And what we're doing here is an I minus minus. Now with each iteration, why don't we create that temporary variable I was talking about, where I just take the message list and I save in the current element. If log message contains the word that I'm looking for, well, we'll add it to RTN. We'll remove it from our message list. And I don't have to do the I minus minus in this case because we're going from end to beginning. Let's try this out. It's effectively the exact same thing, except I'm just going from end to beginning, and notice that we don't have the skipping issue. Big deal, we managed to remove the 3 occurrences of disk that we wanted to, right? And so now this is what it looks like. Importantly, I need to check to see, because here, not only is this removing, it's also returning the elements. Why don't I save those back into this list that I already have created? That way we can easily print off our list. At this point, list should contain only the things that got removed. Here is my log. Here is my list, which is has nowhere near as neatly formatted. And notice that these 3 things that had disk got added. What's the problem now? It's a good thing we checked that. I didn't really think about that. What's our problem now? These 3 things that got removed, they're in reverse order because I went in reverse order. 2 ways you can fix this. 2 ways you can fix this. Big brain, something you're not supposed to know is that we do collections.reverse on our list that we plan on returning, RTN, which will actually switch the order of it. And as we can see here, ta-da, big brain. Now, you are free to use this on your FRQ. Collections is a utility class that allows you to work with collection objects. Those include things like list, which obviously includes ArrayList. This is a static method. I can tell multiple reasons. For one, I did not create a collections object. I'm referring to instead a class. This is italicized in IntelliJ. Another way that it's showing me that it is static. You do not have to import this. You are free to assume that anything in Java has already been imported. You don't have to import. You could just type exactly what I did right here and it would work. You would get full credit, right? Because this exists inside Java. You are free to use it. Now, let's pretend you don't know that. Instead of just adding the message at the end, whenever I go to add it, one thing I can do is always specifically add at the beginning, right? And that is at index 0. Keep in mind that add is overloaded. If I do this add, it's going to append. It's always going to put it onto the end. And when I'm going in reverse, that's how I ended up with a wacky order. But if when I add it, I always put it at the beginning, right? The first index is 0, then this should work. I got a few questions, which we're going to figure out real fast. Does this work when there's nothing in the array list? And the answer is yes. Here I'm adding it specifically at the beginning. And even though we're going in reverse, it fixes that. That's a tricky one. That would have got me. So we don't need to import ArrayList. That is correct. ArrayList is already imported. Everything's imported. Don't worry about import statements. Okay, last thing I'm going to show you is we can clean this up. Largely because now that we're using a for loop and we're referring to maybe some element at some index, we could, in theory, combine these 2 statements, right? The only reason this if statement has has braces because it has multiple statements. But if you keep in mind that remove is overloaded, Here, if I specify an index, it's going to remove the element that is at that index. In this case, it's log messages, and then return the element that got removed. What that allows me to do is then add it. I can actually collapse this into one statement. We want to add to RTN at the very beginning whatever I remove from message at the current index. With that, I should be able to get rid of these braces. This log message is still pretty cute. I don't need it as much now because there's only one reference to log message, so maybe I clean that up. Now this for loop actually only has one statement. I can get rid of those braces. Here's what we're doing. We're looping in reverse. I'm starting at the very end, going towards the beginning. I'm going to ask, does the current element, which is a log message, contain my keyword? If it does, I'm going to remove it. The stuff that's in the parentheses will be done first, right? So we're going to do the stuff that's in here first. We're going to remove it from the message list, the current element. I've already verified that the current element is a log message that I want to remove, so I'm just going to remove it. Because I'm specifying an index, this is not only going to remove it, it is going to then return the log message object itself, which I'm then adding to the beginning of RTN. Let's try it. Everything should still work. Here is my system log in the beginning state. We see that the 3 disk elements are no longer there. They are in this list that got removed. Let's chill.